Today we'll review for our test coming up tomorrow. Homework, you can, if you're done, ready to turn it in, you can turn it in tomorrow, but I'll let you hang on to it till Monday. Just don't forget to bring it Monday. Okay. You will be allowed one sheet of paper for notes, formulas, anything you may think you need, and the integral tables that I handed out to you, so you can have that with you. Although many of the problems I'll tell you, you can't just use the tables on, but at least they'll be there for parts of it. There will be some parts where you can use the table. Also, on this test, there are only 10 problems. So that means each problem is worth a lot. But as long as these tend to be, I do want you to get done tomorrow. Or in an hour, maybe. I will allow you, like normal, to keep working on it. I'm not restricting you to an hour, but just have that in mind. If you want to start early, I'm in here practically all morning, so. Well, the problems that will be on here, first of all, find the antiderivative, indefinite integral, however it's stated. Okay. For most of the problems, like I said, you will need to show your work, not just find the nice little formula that's been developed for you. All of these formulas have come from these techniques and maybe a few others that we haven't looked at, but I want to see, can you do these special techniques? So most of the problems will be doing this without the table. We have looked at our first special technique was the trig identities, and that was working with changing sine squared theta into 1 minus cosine squared theta, or tangent and secant. Know the identity for tangent squared and secant squared. Which one's the plus one, which one's the minus one. I would have to write that down just to make sure I've got those right. Sines and cosines, I've got that one. Not a problem. But the tangent and the secant, I may need to write that one down myself. So make sure you have that on your sheet of paper. And then figure out what do we let u equal, and then du. Du will take care of, hopefully take care of the other part to make it a nice integral. If not, then of course there's more things that you have to do, which we had some of those on the homework as well. So trig identities. Next we'd looked at partial fractions. So know how to take a rational expression, one big ugly fraction, and separate it into smaller ones. Factor your denominator. Now also, in this section as well as in the first section we looked at, which we haven't talked about yet, but the first section was using your table or substitution. We saw a lot of different substitutions. But in that section, we also saw where some of the rational functions we had to divide first, do your long division, then see what it fit into. And we saw that again on the partial fractions. So Make sure you know how to do that. To use the long division, you need to do that when the numerator is what? Okay, the degree in the numerator is more than or equal to the degree in the denominator. If the degree in the numerator is less than the degree in the denominator, then there's no need to divide. But same degree or higher degree in the numerator, you've got to go through the long division, rewrite it that way, and then see what else you have to do. So probably some partial fractions on that one as well. Okay, so trig identities, partial fractions. Then we looked at integration by parts. And that one, well, get your u dv, take one part as u and one part as dv, and then follow the formula for integration by parts. That's going to equal u times v minus the integral of v times your du. So the trick there is figuring out, well, what part do I call u and what part do I call dv? Sometimes it's somewhat obvious, other times you may just have to try one, see if it works. If not, then flip it around and see if the other direction works. So, but integration by parts, make sure you know how to go through that. And let's see, our last section of the integration techniques was the trig substitution. Not just the identities, but trig substitution, where we would let x equal maybe 2 sine theta or 3 tangent theta, something like that, to where we plugged it into our integral, and we ended up with something that would simplify to those trig identities we had earlier. So it kind of built off of the trig identities, and amazingly enough, we can take these expressions in terms of x, change it to trig functions, simplify, don't forget to find your dx, then rewrite it all in terms of theta, and most of the time we could then directly integrate what was left. Sometimes we had to do a little bit more, but most of the time the trig sub, integrate in terms of theta, and then finally go back and change it to terms of x. Now those were the bulk of this chapter, working with the integration techniques. And then what we looked at yesterday, the numerical integration approximating a definite integral, which we used either the trapezoidal method, trapezoidal rule, or I introduced Simpson's rule yesterday during class based on the area under a parabola. So at least you need to have those formulas written down on your sheet of paper. So make sure you know how to use those formulas as well. So it could be 1 or 2 problems on that from approximating. And then, well, since we did introduce these tables, I will let you have one problem where I do say use the tables. No, just one. So now, even with that, you may need to use substitution to get it into a form like the table, but it'll be a fairly obvious substitution. But some of these formulas, we could do it by hand, but It's a lot of them are algebraic manipulations, and earlier in the week we saw a few of them anyway. We looked at the integral of secant cube theta, ran through that, and within that then we ran into the integral of secant theta, so I quickly showed that one. But one problem you'll be able to use the tables on. Now, in some of these other sections, parts of, especially the trig substitution, parts of the problem you may be able to use the table on. Like, and with that integration by parts that I showed you earlier, the secant cube, part of it ended up being the integral of secant theta d theta. Now, instead of you having to show that one by hand, if you run into something like that, or I know in some of the trig substitutions you may run into something like this, any of those, just go ahead and go to the table. And secant, that was number 13. You don't need to show me where you get this one, even though within most of the problems I say use the proper techniques rather than the table. That's an exception to that statement. Cosecant theta, well, number 14, looks very similar. Cosecant theta minus cotangent. And then, of course, don't forget the plus c on the end of any antiderivatives, indefinite integrals. So I think I can come up with 10 problems there that will challenge you in all of those areas. So there won't be a whole lot of anything, obviously, with just 10 questions, but a little bit of everything, 1 or 2 problems on each technique. So I only was able to give you 1 on some to keep it down to 10. But okay, any questions? Any particular problems that we need to look at?